Hello, I'm going to go over this lecture, Characteristics of the Atmosphere. And what we're doing is we're just talking about the very basics of Earth's atmosphere. So we see this image from space and it shows Earth right here. And you can just make out this blue layer, which is showing the atmosphere. This is what it looks like from space. So Earth's atmosphere is a collection of gases held by Earth's gravity. So gravity is pulling it down to the surface. There's nothing else keeping it in place. When compared to the Earth, it is very thin. So you can see the atmosphere here is very thin when you compare the overall size of the Earth. All right, let's talk about some of the gases that we're going to find. Now, the primary gas at about 75% is going to be nitrogen. So nitrogen makes up most of the gas in the atmosphere. Nitrogen is an important element in the body of living things. So nitrogen somehow, through the nitrogen cycle, has to get into the bodies of every living thing. And there's various ways to do that, but that is more for a biology lecture. All right, let's continue. Next, we find oxygen. It's the second most common gas. Oxygen is at about 22%. It varies, but about 22% of the atmosphere. It is essential for energy production in most living creatures. So we need oxygen to go through respiration. Respiration is essential for creating energy in our bodies. That's through cellular respiration and the electron transport chain, but it's essential for almost every living creature. Also required for combustion. So if we want to burn anything, any normal types of combustion require oxygen. All right, just one more here. We're going to talk about water vapor. So there's a lot of water in gas form in our atmosphere. Water vapor is part of the system that moves water through Earth's ecosphere. And so in the atmosphere, it'll be gas, and then it'll rain out as liquid water. It can freeze into snow, melt, become runoff, where we have liquid water again, which evaporates, and it's just this cycle. Water vapor is just part of that cycle. Also required by all life for cellular respiration. So water is going to be essential for all living things. All right, last one here. So atmospheric pressure, what you see here is just a little model showing all the gases at sea level, and then as you go up in the atmosphere. So at sea level, there's more gases down here at the bottom, more gas particles than there are higher up. This makes sense because gravity's pulling it down. So you're gonna find more at the bottom than you will at the top. Atmospheric pressure is the weight from gravity of all the gas particles above us, pushing down on our bodies. So even though we don't see these gas particles, they have mass and they can exert a force if gravity's pulling them down. Now, if we take a look here, we see something that should be hopefully intuitive. As you go higher in the atmosphere, that's over here, there are less particles pushing down on you. So you can see this person up the mountains, there's less particles above them. But this person down here in the valley, there's a lot more particles pushing down on them. So there is less atmospheric pressure up here in the mountains because less particles. Down in the valley, higher atmospheric pressure because more particles. All right, I hope this helps. Thanks.